Also part of what
Will you guys be talking later or up front?
Whatever you
Okay. Well, it doesn't matter for the meetup, but just for video.
I can sit up here maybe so that you can see.
Okay, sure.
first one until you get out.
So when we
We had to install data sets somewhere up there because of all the inmates. Just they have left those guys free, they get stabbed.
you could do that with
Yeah, so I really like it.
It's cool. So you can use it 2 hours to kind of
Yes.
or
Yeah.
calibration. You can use this too. Like if you have robots, you want it to extra lines. That's an only letter for day accomplish. So
It's worse.
that's what
You
it
can
is.
see
There it's a lot.
the next thing you go through is that's a real interesting story. It's it's south,
they just got in
kind of west, more south southwest. Avery Island, everybody knows where it is. No, it's not far from here.
but I came across it and I went to their
It's a really cool place.
it's a whole series of
Take a tour, walking the
Xsens
through the
they don't try to relate, they also they just assume the world's going that way.
yeah,
So
so
they fly.
you try to
Because
do
I found out one of these running
Well, the robots.
in Arizona.
That's me.
Oh,
Great Popeyes. They serve here there.
you know what? These cannot run. If you do go in a straight line, close your
You
eyes,
go to a
and
gator show.
140 mile, they can't catch up to you.
There's one in Big
But make it
it's
straight
right by
line.
Shreveport.
They
Big gator show.
don't have the energy to go.
But you guys go out into the water and take like a chunk
So
of
it just said to run indoors.
Oh,
And
yeah.
it's
Do you know why?
Way back.
like that. Oh no, if you want to get away from
We are and
because they're more with the hot stuff.
Do you know why?
you can start whenever you
It's not really
want.
the correct term, but
Alright, thanks everyone for coming. I'm going to give a little bit of background on our company if you're not familiar with Xsens, and then we'll talk about the product lines that we have. And at the end, we're going to do a little raffle for 2 of our MCI1 series sensors. And we're going to give one away to what we think is kind of the best idea, how you're going to use it. And hopefully once you use it, you can share with us how it went. And then we're going to give the other away just to a raffle like with a business card or whatever you have. So keep that in mind while you're watching this and think about some fun ways to use it. So our company's name is Xsens. We were actually founded in 2000 in the Netherlands, and that's where we do all of our R&D, all of our development currently. There's about 70 people based over there. We also have a sales and support office in Los Angeles, so that's where we're based, and there's 7 of us up there. In January of 2014, we were acquired by Fairchild Semiconductor, based up in San Jose, so we're now part of a much larger organization. And I can go into a little bit about why that is towards the end of the presentation here. And feel free to stop me anytime if you have questions. So basically what we do, we don't make our own MEMS. We purchase the gyros, we purchase the accelerometers, we purchase all the magnetometers, barometers, whatever else we're integrating. And then our value add is really in the sensor fusion. So we were founded by some PhDs over in the Netherlands. And they were it started out more as like a sports application, kind of like a Garmin type application, and since then it's evolved into numerous other applications and products. And kind of those 3 industries that we're in now are industrial, which are the single sensors that we'll mostly be discussing here. We also have an entertainment market, and that's a full body suit that's integrated with 17 of our sensors. Those are used for motion capture. They were used in the movie Ted, the movie Transformers, a number of other movies like that. And then we're using motion or movement science as well. So for some rehabilitation or gait analysis with the universities, also some health sciences and some sports analysis. So you can analyze, for example, a baseball swing or a golf swing and see how to improve there. But going now into the industrial market, basically where we see ourselves fitting is kind of in this orange circle here, which is called industrial. There's a number of higher end and lower end sensors that span this kind of marketplace. And the highest is like a strategic fog-based type of gyro, and then down at the lower end is these consumer sensors that you find in your iPhones now or your phones. A little bit just about our history. So I mentioned we started in 2000. We came out with our first sensor, if you're looking up in the top at the industrial, in 2003. And we've since iterated on that all the way to what we call our 4th generation MTI. And that now looks like this guy. And this one was came out in 2013. And since then, we came out with what we think is kind of a revolutionary sensor, and it's all the same functionality, but in this size. And so this is really where, you know, the robotic applications and the drones and those kind of things are starting to come into play. So one nice thing, and one thing that we think sets us apart from some of the other people that are making small sensors like this, is that everything was developed for the higher end industrial sensors. So we have a very robust sensor fusion. We have a very robust APIs and software that go along with this. And everything that was built and made for the MTI, what we call the 100 series and the 10 series, it's all applicable down at this low cost sensor as well. So looking at the 3, what I call series that we have the MTI 1, the 10, and the 100. The 100 is our highest end, most accurate, very resistant to vibrations, and most expensive sense series. And then we go down to our 10, which is kind of our industry standard. It's reasonably priced. It's been around for a long time. And then finally down is our low-cost, high-volume MTI 1 series. It's meant as a surface mount device, so kind of for like higher volumes and lower costs. And within each series, we have a number of different options depending on the outputs you need. We have the 1, 2, 3, 10, 20, 30, 100, 200, 300. And what that means is with the 10 series, or the 1, 10, and 100, you get just your sensor data out. So it's all calibrated over the full temperature range, but it's just your rates of turn, your rates of acceleration, and your magnetometer data. If you go to the 20, you get then your roll, pitch, and your unreferenced heading, so your relative heading. And then when you go to the 30, we bring in the magnetometer, and you get your magnetically north reference heading. And finally, with 100 series, we also have the option to have a GPS antenna, and there's a GPS receiver inside, and so then you can get your position and velocity as well. And with the 20, we'll go over this in more detail later, but we have something called active heading stabilization. So even without use of the magnetometer, and this is what you were kind of asking before, if you want your robot or your UAV to just go in a straight line, you don't care if you're going north, you don't care if you're going south, you just say, okay, go straight. We have active heading stabilization, and so that can maintain a heading drift of less than 1 degree an hour, even in an area where there's magnetic disturbances. So looking at the spec differences between the options, the 1 series, the roll and the pitch accuracy is about 1 degree, and the heading's about 2 degrees. The 10 is about 0.5 degree and 1 degree in heading, and then the 100 is about 0.2 to 0.3 degrees in roll and pitch, and about 1 degree in heading. They're all calibrated over a full temperature range from -40 to 85. The interface for the higher end ones is mostly serial. You can choose RS-232, RS-485, 422, UART, and then with the low one, or the little one, we also have SPI and I2C compatibility as well. The mounting, these larger ones are just mounted with screws. The smaller ones are meant to be a surface mount device. We also have a development kit if you do want to use just a USB interface and kind of mount this to something for trials.
Question.
Sure.
Just for the dummies, what does that roll pitch means, and what does heading mean? What?
So roll and pitch, so
Uh-huh.
it's measuring your roll and pitch, and so it can measure it to within about 0.2 degrees for the highest end.
Oh, the.
If you imagine flying, yeah.
I see.
Roll,
So if you- yeah,
pitch,
yeah.
pitches up and down, roll is.
I see.
And yaw is heading,
And heading is what?
is yaw, so your
So heading is
direction,
this rotation.
your rotation.
Yeah.
I see. So that's on the x-y axis. This is heading,
Yes,
and then this is on the other axis. It's the
roll,
roll.
and then
And that
pitch.
kind of goes back to like a aerospace or nautical navigation terminology. So
Okay. And the degrees, those 2 degrees, it's the accuracy
That's
of measurement.
accuracy.
Okay. Thanks.
Accuracy per hour or something? Sorry.
No, that's just a fixed accuracy. So
Oh,
over
oh,
whatever.
compared to the real deal.
No, I mean, if I'm looking at instantaneous heading and I want to fly on a heading of 350, I might go 348 to 352
Right.
for the MGM one.
Yep.
And the drift is on top of that.
No. So when you're using the magnetometer, as long as you're in a good magnetic environment, there's no drift.
Okay.
So it uses the magnetic fields to correct for the drift, the heading drift.
Yeah, so if I'm trying to fly on a 350, I'm flying on magnetic 350, not really. Okay.
Yeah. And you can put in your location in Earth, and so it does compensate for
Yeah.
that. Yeah.
But that's only on the more expensive versions?
I know all of them are able to.
They all have magnetic?
Yeah.
Oh, I see. Okay.
It's only on, so all of the different sensors have the magnetometer, and then whether you get the MTI 1, 2, or 3, 10, 20, or 30, or 100, 200, 300 is
It's whether you're doing the calculations on the device.
exactly.
So is there a microprocessor involved in any of these?
Yeah, they all have processors on
Okay,
board.
so
Yeah, and so
that's
that
how-
processor is where we store all the calibration, and it's where all the sensor fusion is done.
Cables,
Exactly.
And
14 or
does it also have some storage? Like
It
how
doesn't-
much time?
Or 14.
It doesn't have any storage. You mean in terms
Oh,
of
yeah,
storing
yeah.
your data?
Yeah, it's about 13.
No, we do have suggestions if you need.
That's right,
So
it's
a lot of
good
people use the
questions.
data in real time, so they're using it to fly a certain direction or drive. But if you do want to store it, you can store it. I'll show you how you can store it through the MT Manager software on a laptop. You can also store it with a data logger that we have suggestions on how to use that.
And it's a recursive column filter, so there is storage on board the way it's doing it, but you can't access it. Or it's not for...
Not to store your data.
Not
And can you ask the device to tell you position or just relative to where you were before? Can
No, for the MTI, so the only one that gives position is the MTI G700 with GPS,
GPS.
and that one does give you true.
And that one's like $5,000.
Exactly. If you buy one. If you want to buy 100, I can give you a great deal.
What GPS are you using?
It's a U-Blocks 50L1 50 channel.
So that's, okay, it's the 50 channel.
Yeah, and actually we have a new product.
It's the MAQ, if you want to know this exactly.
Yeah, and we have a new product that uses a multi-receiver GNSS, so it has GLONASS and
It's multi-channel.
yeah.
Okay.
So within the MTI 10 and the 100 series, you can purchase them either in case, and it's an IP67 rated case, or you can also buy the OEM version, which is just the boards. And you can see on the board, so we have the 3-axis magnetometers on here, 3-axis gyros, 3-axis accelerometers, and then the processor on the back. There's the space. This is where the GPS receiver goes as well. And a lot of engineering did go into this in order to make it the most robust and vibration resistant package that we've had up to date. So yeah, you can buy it that way or this way. And in this configuration, it's about 52 to 55 grams, depending on the GPS or not. And as the OEM board, it's 11 grams. And we'll show you the 1 series a little bit later, but it's less than a gram. Yeah, so this is the 1 series, and it's about 12 millimeters by 12 millimeters by 2.5, and it weighs less than a gram, and it uses less than 0.1 watts of power as well. One other difference actually is that the update rate on the more expensive ones is up to 400 hertz, and the update rate on this guy is about up to 100 hertz. And you can also, if you're just looking at the raw sensor data on the larger ones, you can get it at 2 kilohertz, and this one you can get it about 1 kilohertz, I believe.
Are you outputting quaternions?
We do quaternions and Euler angles.
Oh, Euler
You can
angles.
choose, yeah.
Okay.
So basically what's inside this one series is, we have our 3D, the 3D IMU, and then we add into it a magnetometer and some clock functionality, so you can use your sync in, sync out functionality, and then the processor that you were asking about, it's the M4 processor, Cortex M4 processor.
When you mentioned the 100 hertz update rates, is that just for the target rate and orientation, or can you get position at that rate?
No, so this little one doesn't have position at all. So it's only the one with the GPS that has position. Yeah. But yeah, you can get your orientation at 100 hertz as well as your sensor data. So this is the development kit for the MTI-1, and basically it just comes on a board with a USB, so you can use USB access, and we'll show you our MT Manager software. It's very easy to get started with it. You basically just plug it into your computer, it recognizes it, you pull up the software, and you can do all of your measurements that way. As I mentioned, we do also have I2C, SPI, and UART functionality on the MTI-1. There's also a number of drivers available. So there are ROS drivers for robotics, and there's MATLAB drivers. We have a lot of code examples, so code in C++, code in, all sorts of things. You can run it on Linux, you can run it on Windows. There's a lot of support in that way for this.
We actually have a full API that is basically all the processing can be done on board, and just it can spit out quaternions or Euler angles, or you can choose to have all the data going into your software and your host processor, and it can be crunching all the numbers and running the filters, and it can all be done off board. And the benefit of that is if you want to use the full rate of the 1 series 1K raw sensor data, you can be sending that all and be using that in your processor as well, but also be crunching the filter to get the orientation on your host.
So this is just a little picture of what the software looks like on the right-hand side there. So you can see there's a 3D representation of the device itself. So as you turn it, that 3D representation moves around. And then you can graphically see all your different outputs, your orientation, and your sensor data. You can save it and export it for using later. You can also change all your settings in here. As I mentioned, there's different filter settings. So for this one with the MTI G700, for example, we have an automotive filter, and that then uses holonomic constraints, knowing that the wheels of the car are always on the ground, knowing that you can't, if you're not moving forward, you can't be turning in a 360-degree turn or any turn without moving, and so you don't get, that way it stops the heading drift. So if you're just sitting there and you're using GPS, it doesn't always know how you're heading, but with our constraints, it knows that if you're stopped, it shouldn't be changing.
That's clever.
Yeah, so there's a number of different filter settings for specific applications like that.
Well, you can cheat on the nuisance test.
Yeah, yeah.
What kind of filter is
It's an extended Kalman filter.
okay, yeah.
Also, with any of them, you can set the filter setting. So if you buy the MTI 30 or 3 or 300, you can set the filter so it acts like an MTI 2. And so it's using what we call that active heading stabilization that I mentioned. So for example, if you're using it and you have a great magnetic field and you want to know exactly where you're going, you would run it like an MTI 30. If you then go into an area where the magnetic field is very disturbed and you just want to know, okay, am I going straight, you can just change your filter setting and use it that way. So you don't need to buy 2 separate sensors to do 2 different kind of applications.
Can it tell you if it seems unstable, magnetic?
You can basically
situation.
tell if the magnetic norm is varying wildly,
Yeah.
then you know that you're not in a homogeneous magnetic field.
So
That'll
the
come
norm
right
is
out of your EKF.
Or you could buy 3 of them.
Yeah. Yeah.
so but okay. So the norm is basically the Euclidean sum of the spectrum. Or what?
Yeah, just what the 3 channels of magnetometer are reading. Yeah. So you don't want that to change too much.
Yeah. Okay, I mean, it's orientation. Actually, orientation. Do you completely disregard that, or if that goes wild, do you also say it's impossible? Magnitude and orientation, and okay, magnitude is obvious; that should be the same. Orientation is crazy things.
I know that we have kind of the filter itself is always monitoring, and there's a.
Oh, okay, if it has large variance, then it's.
I don't exactly know what it's doing in terms of checks for that, but there's a lot of secondary checks like that.
The covariance matrix inside the EKF will tell you there's something screwed here.
Yeah, and I think the main, I guess, bigger picture is that if you do change the magnetic disturbances near you, you're gonna confuse the sensor, and it's gonna think that magnetic north is, now this way, where it should really be the other way. So.
And there are some things that our filters can do. So we do have something called a magnetic field mapper. And so if you're mounting it to a metal object, you can mount it and run your field mapper, and it'll then ignore anything that's a continuous magnetic field around it. And then it's just if the magnetic field is changing that it sometimes has problems. And even then, our filter, like if you're flying a plane and you pass something that has a magnetic field, it'll ignore that. But if you're next to, for example, a motor and it's like continuously changing, that's where you tend to run into problems. So that in that case, it's better to run the active heading stabilization.
Does the SDK allow for you to provide your own GPS? And does it allow you to run that onto your host computer?
No, you can provide your own GPS, but you would also have to do your own fusion of it. Yeah. The 1 series, this one, probably middle of the year, it will allow that because it's obviously too small to have its own GPS receiver. But we are planning to take in a receiver and probably give suggestions on which ones to use or something. But yeah, that is in the works. Playing with the dust. So just looking at kind of some of our value add, because I mean, you might say, well, why can't I just buy a combo sensor? Or why can't I just buy accelerometers and gyros and run some Kalman filter that I find online or something? So basically, there's a couple areas that we add value. One is really in the calibration and the test. If you look at when you buy a bare sensor, it looks like the performance looks like that bell curve down on the bottom right. And basically, you have to throw out the top 5% or the bottom 5%. And once you solder them down, they just don't act like they acted before. And so we do that for you. You don't have to solder it into your large board, large expensive board. We do all of that, and everything we give you is a working unit. So we test everything at the component level, and then again as the full unit level. We also do all the calibration that I mentioned over temperature, so it's all from -40 to 85. All the specs that we give are over that full temperature range. They're spec'd over that full temperature range, and that's we do the calibration for gain, bias, voltage, sensitivity, everything. And then the other value add is in the sensor fusion itself. So we, like I said, we take the magnetometer and we do a full time synchronization and calibration and axis alignment with that and the other sensors. We also have the onboard timing, and then we do all of the onboard strap-down algorithms, the coning and sculling. So basically on these larger sensors, what we do is we take the data in at 10 kilohertz and we downsample to 2 kilohertz, and that's where we spit it out in terms of the raw calibrated data, and then from there we take it down to 400 hertz through the Kalman filtering.
By axis aligned, you mean if it's not mounted perfectly horizontally on a system that it'll work?
Yeah. So when we mount them on here, we do a good job of getting them perpendicular, but it doesn't have to be perfect because all of that comes out in the calibration that we do. And then when you mount this guy, you don't also have to mount it, so that it's perfectly heading in the direction of your equipment. You can mount it anywhere. You can mount it upside down, sideways.
When it uses the accelerometer to determine what down is.
Exactly.
So does the GUI that you provide have a calibration procedure that you can walk through that's telling it to move in a certain pattern?
So you don't have to do any calibration except for if you want to do the magnetic field mapping. But all the other calibration is done, it's just in the sensor itself, so you don't have to do a calibration on your equipment. And as I mentioned, so we've been around for about 15 years now, so all of our algorithms are time tested, and like I said, they all transfer from the high end down to the low end. And the new feature is the active heading stabilization, where even in an area of disturbed magnetic field, you can still get a good stable heading.
Actually, what happens if you completely lose the magnetic field?
If you lose it,
Basically, if the magnetic information becomes totally unreliable.
I guess we would just not guarantee the. Well, it would just the gyro biases would start at some drift, I guess.
yeah.
No, I mean the question that I want to get at is if you mentioned in the announcement that you have MEMS sensors and okay they last for a while but over time they drift, and I was actually trying to get at the accelerometer and gyro drift that you have there.
So the specs on the gyro for the MTI 100 series are 10 degrees per hour, and the specs for the 10 series are 15 degrees per hour. And that's just on the bare gyro. So that's not, counting in any of the filtering.
Is that nonlinear drift or is it?
I don't know.
I think it's just I'm not sure.
So now I was just going to go through a bunch of different applications and how they're kind of used, unless there's more questions on the specifics of the sensors or the specs or anything. But we do have a couple of flyers in the back if you want to see
The little one, 1K budgetary pricing.
So the budgetary, for 1K, it's about $125. Yeah. It goes down to less than $70 in about 5K. It's about 5K. Yeah. And if you want to buy a single one, so these development kits that we have here, you can actually buy them on DigiKey and Mouser, and also on our web shop, and it's $449. And so that comes with the board, the sensor, the cable, and all the software. So looking at the various applications, basically we span air, ground, marine. We also span all sorts of different applications: control and stabilization, measurement correction, navigation. So I'm just going to run through some examples of it, and you can use your imagination. That there's a number of other ones. So for example, in heavy industry, we're used on some cranes that are used in mining applications, for example. They can be for GPS aiding and tilt correction. They can be used for digging indication and tip over alarm. So for example, one customer puts it on the end of their crane, and by knowing the location of their crane and knowing the load on it, they use force sensors that they combine it with. They're able to optimize the lifetime of the crane by only keeping it in certain regimes when it's loaded a certain way. On the right-hand picture, that is cargo loading. So basically it's used on a ship where a crane is moving some cargo around, and you put the sensor at the bottom towards the cargo so you know the direction that it's turned, basically, so that you don't run into things. It's also used quite a bit in marine electronics. It's used on the ship for roll stabilization of the ship itself. It's used for satellite aiming and pointing, and then it's also used for some radar correction. At the bottom there is an ROV, so there's a number of ROVs using this for actual navigation as well. Agriculture, again, it's for the GPS tilt correction. And what I mean by that is basically if you're kind of going up a bump or around some corners and your GPS is coming down, it will look as though you're off by, depending on how far away your GPS is from the bottom of the tractor, it'll look like it's off by a meter or more. And so the tilt correction, if it knows the tilt of the vehicle, it can compensate for that. It's also used for heading aiding for navigation and for tool orientation. So we have some customers using it on sprayers, and they need to know or point the sprayers in particular directions. And then on the right is some aerial imaging. So a lot of aircraft or both drones as well as manned vehicles are using this on their equipment to help with the mapping of the fields. In robotics, we were just at Robo Business the other week, or the other month, I guess, and there are so many service robots out there now. So it's kind of going to be, I think, an exciting time. But a lot of the service robots now are used in hospitals or hotels, and in that case, they don't necessarily need a sensor. They're using the walls to guide them to make sure they're going in the right location or direction. But they're also moving more into warehouses, and so you don't have the walls as your guides anymore. And so that's kind of where these sensors are coming in, and they're trying to use them for navigating a bit more. Also, when they were $1,000, it's a little bit expensive to put in your $5,000 robot, but now that there's an option at $70, it's making it more attractive for them, even if it's just for improving their performance. Some professional tools, drilling directions. So we have someone using it on a drill where it goes down and is trying to bore a straight hole and needs to make sure that the drill is continuously pointing in the downward location. On motion platforms, sometimes this is just used for correcting a robot. So not correcting, but testing. So making sure that it's staying within its right parameters. They're also used in virtual reality, so for head trackers. We've combined with Oculus, and they're used for some head tracking applications, hand gesture sensing. And there was a really cool application you can look up online by NASA down at the bottom right, where basically pilots, it was a virtual reality, but they were able to fly a real plane, so actually be flying and see the real world outside them, but also see an overlaid virtual image. So they had to refuel in midair, for example, and they saw a virtual plane that they were trying to refuel while still being able to see their real surroundings as well and flying a real plane.
What was your sensor doing for that?
So our sensor there were two things. It was in the plane, so knowing exactly where the plane was heading so that you could do the virtual image
Oh, I see.
in the right place, and it was also on the pilot's head, so it knew where the pilot was looking and where the pilot was relative to the plane, I guess. In the medical industry, again, there's another one of those service robots that I mentioned, also for camera systems and head trackers, again, and for some ultrasound scanners. Some first responders where they're trying to take people out of the equation. On the right-hand side, you see, I think that's a landmine detection unit, and so they need to know, where it's going and where it's heading. They're also used for micro UAVs, ground robotics, and then there's some pedestrian navigation applications. So when I say that our sensors, they don't give position, there are some people who have been clever enough to add in other outside sensors or other outside feedback to be able to get position. So for example, on the pedestrian navigation, they're using the double integration to get position, but then to correct for it, they use a foot strike, for example. So every time the foot hits the ground, they can zero the accelerometers and the gyros and then kind of reset from there. So in that case, they're able to see where their people are even when they're inside buildings. Some automotive testing, particularly on the high-end, these high-end ones that are able to really see some good vehicle dynamics. A lot of issues with some of the other sensors is if you're kind of like banking on a turn or you're doing high accelerations, sometimes you see errors with other MEMS sensors, and so people have been able to show that ours really work well in those type of applications, those like high performance applications. And then I think I mentioned some UAVs. They're used both for control of the UAVs, particularly the small one now coming up in some of the drones. But some of the larger ones are also used in some of the payloads, so for camera, gimbal stabilization. They're used in a lot of the filming. This one down on the bottom left, I think that particular thing is called Sarah, and it won an Emmy or a Grammy or something like that for the filming that it did
I can see.
with our sensor. Yeah.
What's the company that's buying these things?
That one's called, I think Sarah is what they called that particular plane. I don't know what the name of the company was. I don't remember. I can look it up.
Yeah.
Yeah. But then for camera gimbals, there's a number of companies out there. Gyron, Netman Systems. They have much larger camera gimbals, and they mount them on helicopters. They mount them on fixed-wing planes. And what our sensors can do is they're using them for a couple things. One is just for setting the horizon. So making sure no matter which way the helicopter's tilting and turning, the sensor's always keeping the camera level. So you get a very level, stable picture. The other thing they can do with the MTIG 700 is you can actually set the camera to stay locked on a particular longitude and latitude. So the helicopter can move all over the place and it just stays stable right on the thing that you're trying to film.
So we're not using that on handheld Steadicams.
We've talked to Steadicam. There's what's this guy's name, Bob or something? Does that? I don't know. Yeah, I think he's tested ours before. I'm not sure if he's using it or not. I don't remember. Yeah, there was he mentioned something that he won some award also using that camera. Yeah, so that's basically our product line. We're also going to show you an example of running one of the sensors, and an example of the software, so you can kind of see how it works. Do you want to do it on this one?
Sure.
Or?
Yeah.
Let's pull it up.
Oh, actually, could I take a look at your OEM thing there?
Sure.
In blue
It's gonna be
circus
fun with this
like
business.
that.
Yeah. Do you want to do the larger one or the little one?
Little one.
I should rub my feet on the carpet more before handling them.
Yeah. So this development kit allows you to use USB even the sensor itself is supposed to be SPI or UART. So it might be a little challenging with the resolution here, but be able to see something. So this is our MT Manager software, and like Kendra said, it's useful for our whole range of sensors, but the development kit should work. This was my sensor, so using a new computer is new to. Oh, it's showing up as a mouse.
Yeah, no, it doesn't.
Do you have your sensor?
No, it does the same. You just have to unplug it and plug it in.
Sorry, sometimes the drivers make it think it's a mouse. It's not like it's accurate.
You run it on yours.
Yeah, I'm just using my laptop. It's gonna take a second, sorry.
So yeah, another nice thing about it is because all the sensors use the same platform, you can design around one of them, and then if you have like higher or lower end requirements, you can just swap the sensors in and out.
So, question on this disassembled sensor. So, what are those two ports? One is looks
So
like
this one, it has the GPS. So this is for
GPS
GPS
port.
antenna and
Okay.
for the power cable.
Oh, okay.
Well,
And-
power and data.
power and data.
Yeah.
What's that connector called?
It's a Fisher connector.
Okay.
Yeah, so it's just a 12-pin push-pull
Okay.
kind of connector. I think we have one. I can show you. Yeah, so basically if you buy the larger sensor, the development kit comes in a little suitcase like this, and it's just, this is the USB cable, so it's just a
I see.
push-pin, 12-pin connector, 9-pin connector.
What's wrong with the end of that?
Sometimes on mine, for some reason, it shows up like a mouse. It doesn't, I don't know. I'm
And
not
I think
exactly sure.
we probably have a, I don't know what it is, maybe FTDI board on here, whatever the USB to UART driver doesn't always install. But since I've used it with this laptop, it should work.
Good.
Oh,
Let's look at that. Oh no.
Does this software work on Linux?
Yes.
It doesn't yet work on Mac, but it works everywhere else.
Yeah. So basically, this is the screen. I apologize that it's a little bit small, but basically, it just shows you everything, or a few things about your sensors, because on our other product range, we oftentimes use many sensors because we have this full body suit that has 17 sensors, and the whole system kind of comes up with uses biomechanical constraints to come up with a real good estimate of your limb position. So this software can be useful for some of those applications too, where you'd have a whole slew of devices showing up. But in our case, we're really only worried about the one. So let me bring up maybe one at a time these items, but you can basically show the orientation, just a little 3D representation of your sensor, and just for the basics, the pitch roll and yaw are shown here in Euler angles, even though I'm probably sending them over as quaternions because this is, Euler angles are the most intuitive way to look at it.
Are those values for roll, pitch, and yaw? Are those absolute or relative?
Right now, I will skip over here to the filter settings tab, and basically this is where we can set between those filter settings that Kendra was mentioning. In this case, I have it set for general, so it is using the Earth's magnetic field to do a referencing heading to the magnetic field. If we do this VRU general filter profile, that's the vertical reference unit. That is the one that only uses the active heading stabilization, but it does not use the Earth's magnetic field. It's just a general. It's just a referenced yaw output. So basically, when you start, it's gonna set that as the 0 point for your heading. And our spec is that over an hour it shouldn't drift more than 1 degree from that reference. That if you're moving around, if you come back to the same point, it should be within 1 degree. So I'll just leave it on. Well, I'll leave it on the VRU and just show you how you do that.
But the roll and the pitch are always true angles.
Actually,
Because that's just using gravity.
Yeah.
Right. Actually, I don't think I can
Set it. Yeah, that's
set
weird.
it.
Does it show on here or no? Oh,
Oh,
there you
yeah.
go.
But basically, this also is the place where you put in the position if you're worried about the declination. So if you wanted to make sure your heading was taking the proper magnetic offset for your location on Earth. Right now, I think this is the position for the headquarters in the Netherlands.
Yeah, we're low.
Yeah.
4-1-18.
Yeah.
This is in Canada,
Yeah. Well, it's in the Netherlands.
yes.
And then we also have a way to estimate gyro bias. If you keep the sensor really still, press this, and for 6 seconds, it'll look at the gyro biases and try to estimate that. We can also manually adjust the rotation matrix so that if you do have it mounted in a different position on your, or a different orientation on your vehicle or robot or hand or whatever your unique position is, you can change the rotation matrices. A couple other things you can change basic communication options, and this is also where we show the offsets and calibration parameters that were, the unique calibration parameters that were measured during the factory calibration. And they don't do you a whole lot of good to look at them, but this is just where it shows that.
But those are the calibrations that you're applying.
Yeah.
For that particular device.
Right. So it would be totally different if you hooked up another one. And it also is where you wouldn't know exactly why the numbers are changing, but you would see the numbers change if you did a magnetic field calibration. I can even show you if anyone's interested. That software, it's kind of cool. It visually shows you what the magnetic field is, where it's disturbed, I guess. I'll run it briefly real quick. It won't maybe be perfect, but I'll show you just because it's kind of neat. And then we also have the raw data, but I don't know if I can resize it well in this small space. There should be 3 graphs, and there's no way to scroll, but basically our acceleration is shown here, so if we're not moving at all, we'll be showing the gravity vector in the z direction, and then basically just the biases will be showing up. So I could zoom in and show the biases, but
is there a maximum rate of rotation that it can handle?
Yeah. So we actually have multiple products. So the kind of smallest one is 5G acceleration and 450 degrees per second on the rate of turn. The higher G one is 15 and 1,000 degrees per second. And on the 1 series, is it the same?
No, it's actually higher. It's 16G and I think 2,000 degrees.
So what was the cheapest one?
Well, this is the cheapest one, the little guy, but it's actually a higher G. It's 16G and 2,000 degrees per second, I think.
Huh.
And then I can't show the ray of turn videos, but and then the magnetometer would be down there as well, where you could see, like if there was magnetic disturbances, you could see it. But unfortunately, I can't really show that here. But and then the last one is.
But so you can see that even we're not using the magnetometer now, and you can see the yaw is staying stable at 22.4 degrees. It's not drifting.
Here's our orientation graph every time.
Maybe just do a big power supply.
That's the main thing I want to show you on that software. Unless there's any questions, I'll show you the magnetic mapping, because it might be kind of interesting. I think that's it on this. Oh, I actually do have one thing that's kind of interesting. The device itself is outputting a kind of our proprietary, not proprietary because it's like a secret, but our proprietary communication protocol, which we call the Xbus. And I guess this window's a mess. There's buttons to make it so you can see it, but it just basically is a really cool tool here where all the messages that are coming through are recorded. You can pause it and you can just click on one of them and it'll parse the message. So it makes it really, really handy when you're integrating this into your system and you're building your parser to get the message data. You can use this really effectively because it'll decode each message and tell you what's in there I wish I could show you.
Actually, the servo should have a permanent magnet in there, right?
Yeah, you can. I can't. Let's see if I can get the magnetometer up on the screen. If I close this, I can.
So it
There we
works,
go.
works or doesn't work. So not in the front of the projector, of course.
You gotta hold the unit
So here's
steady
the
and move the thing
magnetometer.
over it.
Let's see. Oh, the
You
cable
can go
is.
around the corners. Yeah.
Let's see.
Even maybe your cell phone might have. So the
Oh yeah,
black line is the magnetic norm.
magnetometers are responding here
Yeah.
too.
Let's see if I can open the. Oh, sorry. Oh, there we go. That's.
You should try to put the unit on that table and move the motor around.
Oh yeah, that'll work. So other way around. So,
Yeah, so you can see the yaw's not changing, your heading's not changing, even though you're
the magnetic
disturbing.
fields should change a little.
the magnetic
Changing a
field.
little.
Changing too much.
There
maybe a
you
little
Yeah,
see
they
it
change.
changing,
Yeah. Okay,
Yeah.
got it. Oh. Was worth a try.
Yeah.
Sometimes
Yeah, so
the
I mean.
phone will do it too.
So,
Oh, yeah, look at
yeah,
that.
Oh, there it is.
But see, you can see the heading staying stable. It's not drifting even when you're putting this disturbed magnetic field on. That's because we have it off.
That-
Yeah,
so
if you put it on, you would
it's
see
actually,
it change. Yeah. But we can show you. They want to see.
Oh, okay.
Yeah, that's actually a pretty large angular rate. I mean, there are, I suppose, applications, but we find a lot. The support requests that come into the office. So many of them are someone says, "Yeah, I put it on my desk, I picked it up, and I went like this." And then, the filter's not perfect when I say it back down. Well, I think this is really a lot of, rotation that you can do with your hands.
More than you would see in normal application.
So, but the filter will detect that and have a.
So he wanted to.
When it's
Yeah. He wanted to see the difference in. Well, right now it's kind of moving, but how the yaw stayed stable when it was in VRU mode.
Let me see if I can do it with my phone again.
But then see what it looks like when you put it in general mode compared to that.
I'm trying to make sure.
Yeah, it's hard because the cable pulls us a little too.
You could say like a propeller blade or something.
So
Helicopter
it
blade.
should be- It's not doing as much. Oh yeah, it is.
Well,
Oh, you're hitting it though. Yeah.
I know for a particular rocket. like
I'm trying to get it
Delta Titan,
steady.
it was like 0.3 hertz. It was actually really slow.
screen stabilization or what?
Let's set it back.
Because I designed it, because I had to do some
We put it on high magnetic dependence.
They don't need it to spin so
That's
fast.
fine.
Yeah. So we could take
Did it back.
Still moving already.
Yeah.
All right.
So see there, since there's some magnetic disturbance.
Yeah. So the filters, it's still you can see able to filter it out some, but if you hold it there for too long, it winds up shifting towards that magnetic field.
So this is with the magnetometer corrections disabled.
Yeah. Yeah, and it's hard to see exactly because some of it's just pulling on the cable, but since it's so small.
Yeah, it's drifting now.
Yeah. Yeah. So even with when you're using the magnetometer, if you was just to move the phone around, it still is able to stay pretty stable because it can ignore those kind of things. But when you just hold it steady, it gradually will shift towards that new magnetic norm. Okay, so yeah. So, any questions? Otherwise, we were excited to kind of hear how.
Actually, I have one more thing.
Oh, go ahead. Sorry.
The magnetic.
Oh, the magnetic field.
Oh, I didn't install on this laptop. The old version. Not this sensor.
Yeah.
I didn't install. Oh yeah, here it is. So this is cool. You can basically see a visual feedback on what you've captured. So while I'm doing it, I'm just trying to slowly kind of turn it through the whole region of interest, the whole sphere really. I'm not going to do a very good job, but I'm just going to show you what's going to spit out. So you can see where I have not done a great job. It should be covering the whole sphere. Where the magnetic field pre-calibration is really bad, this sphere will not be a sphere. It'll be an egg, or it'll be oblong. So basically, it's not too bad to begin with here. What you want to see is the norm after the calibration, which is this blue, to be steady. I mean, 1 is ideal, but as long as it's not varied over this whole, all the samples. So this is a pretty good calibration for what we saw there. So anyway, it's kind of a cool
What's
tool.
the bottom trace, the squirrely?
That was the before. Oh, you mean on the right hand side? Or?
right.
Yeah, that was the before magnetic field mapping.
How the norm changes between the samples, so it's kind of like time on the x-axis. But, so this can be expected to help quite a bit. So, yeah, that was my only other thing.
What's the I guess maximum frequency of magnetic field change that it can detect?
Oh, I don't know about that one.
Well, for example, say you have an application where you're using a UAV to fly over power lines to check power lines. And you're going to have that 60 cycle magnetic field varying over the power lines. What would that do to your magnetic field?
So you'd want to throw out that, or you'd want to use the sensor to detect that, or?
You might want to use it to detect it to see if there's, are the lines hot? That might be a way to tell. Or you could actually just try to throw it out if you just want to check for, visually, like a visual type of.
It's a really good question.
So I mean, if you could use it for various functions like that, but would 60 cycles be too fast for your magnetometer to be able to detect that kind of change?
I don't think so.
Would it swamp it out, or be able to actually see that you get, it's very.
To be honest, I don't know the filtering we do on the magnetometer values. I know a lot better what we do on the inertial data. So
It might be a good detector because the power company tries to balance the 3 lines to where they don't produce, a big magnetic field.
Right, and if you were, especially the high tension
If they did,
lines, there's enough voltage and current over even the linear wire there where I'm sure you'd have some kind of magnetic field change. I was just curious how that might interplay with your system. If you were using it for both navigation and or also for some kind of sensor other than just Earth's rotation, Earth's magnetic field.
Yeah, you probably wouldn't want to use it for absolute hitting on that case. Yeah, for sure.
Well, in the case then, I guess it would kick that out. But I mean, if you could just manually or somehow remotely change it so that you could use it, say, in a sensor mode, and then kick it out for navigation, or get the magnetic field component separately.
Yeah.
But again, it wouldn't be a DC magnetic field like from a permanent magnet, solenoid or something. It would be kind of a varying field. And so that was my question.
Yeah.
What's the frequency response of the magnetometer?
Right.
Right.
Yeah.
So,
You mentioned you had some calibration tables in there for things like variation. Can you change them? Can you adjust them?
No.
We
external.
would be able to at our factory,
Okay, so
but
you
it would
have-
be at like factory calibration. There's
Yeah.
no
Because
calibration needed on the end user point of view.
I don't think people realize the magnetic field does change.
Yeah.
Back in the 70s when I was navigating out here in California, it was 17 degrees off. Now it's 8, so it really changed quite a bit. 20 years.
Which century was this?
Yeah.
Pardon?
Maybe you'd have to replace your sensor.
But you just have to recalibrate.
No, there's a fairly
Well,
specific, if you do any kind of
the man does
flying,
all
the navigational maps, they'll tell you what the deviation is and the rate of change. It's usually printed on the charts.
Right.
And that might be a problem if you're using that maybe at some point in the future when we have a field reversal and there'll be no magnetic
Well,
field.
so we actually have a
Changes
we,
over like 20 years or whatever. It's not
Oh, we do
insignificant.
that. Sorry, in the remember when I mentioned that it was set for the Netherlands lat long? It is using that data, that lat long position
Right.
to look up. It's a lookup table. It's
Right.
got a name I can't remember World.
Every 3 or 4 years,
WGS
you have to adjust
84.
the that's all I'm
There's a newer one out
Right.
now.
So we
Yeah, so we
periodically
put a
update
table
the
and it will
firmware.
tell you which
Yeah.
table's in there. But yeah,
Yeah.
I guess you're right, after 5 years or something, maybe
I was
that's
just
not.
wondering if there's a way
But
to
it's minor.
reach it from the outside to change the table.
Yeah, I don't
And-
think so.
And you can change the lat long from your host processor on the fly too. So it's the unless the lookup table changes.
That's what he's saying,
That's what I'm
is that
talking about.
changes.
Lookup table will
Yes, so
change
we do
with time.
change that with the firmware updates, but that's kind of more of a every
You'd have to do
6 months. But
Oh,
we
no.
send it to you.
Yeah,
So
actually-
we send-
We can do it.
you can do it in the software.
Oh,
Yeah, so there's firmware updates that you can do by plugging it in and running the firmware updater. And so I didn't realize this, but he's saying that if the table's changed when we do a firmware update, the new table then goes in there.
But if you fly with GPS, you can get that from that one.
Yeah.
In your Fusion.
Yep, yep.
well, that was another thing I was thinking about. With all these people using your instruments, do you have a website or something where people could return data to you? So where you could map these fields, go in reverse. In other words, everybody running around with all this data compared to GPS, they could provide you more accuracy on your magnetic map.
I think they just assume
Be a project.
the geographic piece or whatever is usable.
What is that?
Yeah.
5 years.
Right.
David actually came to our meetup at one point from 5D Robotics, and I know you guys, or 5D Robotics use Xsens
Yeah, yeah.
sensors. Could you share just a little bit about that?
About how 5D
Like,
is using
yeah,
it?
how 5D is using it.
So they have a couple robots that they're working on now. One I think is a outdoor robot that's using our GPS module, and it's a defense application. I'm not exactly sure what the specifics on the application though offhand. But they're using a number of them, and they purchased one of the small ones as well. So I
In
think
their
there's
case
always
study, what they're saying is that as they were in development, it was super useful to have our GPS high end, but then as they're productizing their stuff, they're looking at now the 1 series. And they can use the same tools. So
Alright, so yeah, I mentioned we were going to give away 2 of these small DKs, so we're going to give them away in 2 different ways. One, we wanted to hear what some ideas were people had, and if we think it's a cool idea and, you say you'll build it and share your results with us, that will go for one of them, and then the other we can just collect business cards, or if you don't have a card, you can write your name on my card, and then we'll do a drawing for the other one. So, does anyone have any?
I got an idea. I'm trying to figure out how to do it. I want to build a Arduino-driven sextant. I've got part of it put together, the telescoping and the light sensing. But it's a useless thing to do nowadays with GPS. But since I was an Air Force navigator years ago, and used a sextant, I just wanted to do one that was automated. But all these angles have to be dead on. Get down to 1 minute of ours. That's a mile.
Well, I have a mailbox robot that everybody knows I'm working on to drive down my driveway to get the mail.
Oh yeah.
And and GPS. I played around with some GPS, and including a Garmin one that uses the Russian system too, and just not accurate enough to position the robot on the road. So I'm just basically reverting to painting a line down the road and line following. But if this, I don't know, this would be interesting. It might be possible that this could be accurate enough for my robot to drive down. It's like a quarter mile down a mountain to get to the mailbox to retrieve the mail and bring it back. So I'd be interested in playing with it and seeing if it could be useful for that.
Okay.
Now, if I said that I want to take an EEG helmet flying and watch an ARs on it that actually have to connect to it, so.
I actually have a robot.
My application has a lot of straight lines in parallel back and forth. So it put the unit to the real test.
Yeah.
But when you have to, these lines won't go hours and hours, so the degrees will be off. But there'll be lots of these parallel paths that it has to go through.
So is it doing like clean, like
yeah,
short-term accuracy.
Okay. Is it doing like what's it doing when it goes up and down the paths?
Well, it's doing clearing brush or painting
Okay.
lines or
Okay.
it's marking things and
Okay.
cleaning things. So it's a good app. And it's got all this vibration. It's like it's got to track while all these things are going on. So, but it's all terrestrial. It's not flying.
Well, I have a parrot drone, and I want to map, like this room, for instance. I fly this around, map the walls and tables and stuff like that, so I would know where I could go, for that stuff. So I like to, with sonar, I can find out something's there, like a wall. But then use the GPS to find out that location, so I don't forget about it.
Indoors?
Yeah.
GPS?
Yes.
Oops.
No, that's not a problem. It depends on how much crap you got up on the most GPS
in my case, so it's
most
gonna create
GPS will
this,
penetrate 2 floors.
Okay.
and it's like the fusion's already there.
Until the new ones come
Okay,
out.
good. Should be great.
And then what happens?
They're increasing the power by 20 dB.
So, no issue.
That depends on whether the government's going to fund the Block 3s or not. Going into the Block 4s. Block 4s are going to have a lot more output power.
So we're all going to get cooked like a
I'm working on a robot that picks things up off the floor for people that are in a wheelchair. So you use it to keep the slate like level, know that I'm not going to throw something.
Wheelchair or lazy?
Or lazy.
I want one of those.
Don't spill the beer.
Yeah. Well, they might fall out.
In the same application, it could be used for assisting the navigation process.
Yes.
Put them on.
So these.
That's a good idea.
Yes. That's one
That's
trip.
a really good idea.
Remember the paint sprayer guy? He gave a presentation about a year ago. He could use one of these really well. He would map out new slabs for buildings, and he would map out where the electrical and plumbing and everything, structural supports are going. And he'd do it at night when the people aren't working. So right after the slab was cured, basically, peel off the plastic and have this robot go over it and mark all the lines on it. But I don't remember his name. He was here. And so much.
I forgot his name. Do you remember his name? You remember you talked to him afterwards.
What was the topic again?
Construction robot that.
Oh yeah.
Mapping slab.
Yeah. That's in my
Joe was just
I
don't know what his status is.
He had a laser, centered laser somewhere, and it would track where it was in reference to that. But a real world thing, that laser might not be the best way to do that.
You need to replace the Boy Scout compass with one of these that runs on batteries. Boy Scouts, they lost them.
Yeah.
Battery is not a good idea if you're good living in the wilderness.
Low-tech solutions are really
And the
helpful.
spec says 45 milliwatts. That's probably the processor.
Yeah, so I'm working on building components for robots. One of them is a motor control board. I'd like to put an IMU on it, some different IMUs for that. And then I have a school bus that we're trying to automate. So I could potentially try to use your units on that as well.
That sounds scary.
Scary but fun.
Yeah.
Not as scary as the school bus driver.
Yeah, I know, right? That's probably true. Yeah. All right. That was a bad idea.
Or we could speak and do the cards or something. Or we could discuss.
Oh yeah. So do you wanna? Does anyone have business cards they want to give in for another one? Or if you don't have a
they all
card,
actually look the same. Or no, it doesn't.
if you don't have a card, you can grab one of mine and write your name on the back, so you don't just give a piece of paper and we know it's not a card.
Do you all compare your results to other manufacturers?
Yeah.
I know this. I need two.
I think there's two.
Oh man, that's the smartest. Put in a 20.
Just put it at 20,
Oh yeah, yeah. If you put in 449, you're guaranteed to get one.
Oh man.
Yeah.
I have a better idea.
That's the development cost.
Yeah.
Yeah, ours is quite a step above in terms of the accuracy. Yeah. They're more about
Yes, it says mad scientist.
Are you mad?
Yes.
There might be some.
At the moment, I don't.
You can find one.
It's a little bit different, but then I think there's a generic things somewhere. Challenging on those things and they're focused on
Generic. That's a good
motion.
company name. Generic.
No, actually, my Gmail is in the particular elsewhere.
It's actually should say default, right? It's like company default. No.
Everything should be FUBAR. FUBAR.
Yeah,
No, but you know how some databases. That's what I'm printed. No.
Yeah, fair point. That's what I said.
Did you manage
And then
to,
if we include batteries and power supply, what else?
I can do both.
I don't know.
Those guys, they're trying to not get expensive anymore because they're actually fixing up the planes.
Something with their some plans to put all the variables and problem.
The parameters of the project, right? Like this should use all the data transfer.
Basically, so to get a lot of people say the half to 2/3 of
If they have a thing which we can decide on and it collects all the data.
No, we don't have.
But still, it's a good group. We've got a few of them.
Yeah.
Does it have a processing?
So
It has?
No, I lost
Can it local
Giovanni.
Can we not program the process?
So I think I'm going to do Giovanni.
No programming.
Wait a second, man, what you gotta
People come for it to be interested. And I'll do that all day.
instead of a robot that have a mailbox that sits there and then comes back and goes back down.
It's basically, that's basically what it is. That actually basically is what it is. It goes down and brings the mailbox. The mailbox is so smooth that it has the robot. Yeah, I thought about having the robot parked down there. I'm worried about people stealing the robot. So the robot go get the mailbox and brings the mailbox up.
Yep.
I already have a
So
mailbox
there's
that
a lot
does
of
that. When he
customers
opens,
right now.
when he opens it, the
the
mailbox says "Thank you very much."
Oh,
He loves it. I don't know. He loves it now.
No, but like, can they introduce this to the public and then ask you guys to push it? Yeah. Oh yeah, you want to look at it? Sure.
You don't want to insult your.
Yeah, well, I said the biggest in San Diego. You know, Stone is in San Diego.
I had a couple contracting jobs.
Stone's in Escondido. Well, San Diego County. So that's probably why they technically say. I thought so. Stone was bigger, but they're not San Diego City.
Alright, ready? So these are the development kits. Basically, it just includes well, the sensor. It includes the USB with the software on it, and then it has the little cable in there as well. And so you can download the software from here. I think for this one series, that's the best place to do it. Pretty soon you'll be able to download it from our website as well. But I think right now that's the best place for it. And so I think for this first one, we're going to give it to, what was your name again?
Dave.
To Dave. We think it's a great application to be able to show how it goes straight and how then you can set it to turn and go straight the other way. And like I said, you can set it with different filter settings. Yeah, thank you. And then the second one.
I was going to say,
Here,
if anybody needs
your
to use this in the club,
Is it
you can use it.
shuffle?
Yeah.
So I'm going to make it available. So it's not just me using it.
You gotta pose.
Ready?
Scott Wofford.
Oh my god.
Yeah, thank you.
Yeah.
And we have
There will be a test on Monday.
we have some brochures here with the different sensors. So there's the spec sheets for the 1 series and also the higher end ones. And then I'll leave my card, some of my cards with Hansel. So if there's people want them later. Yes. Oh, sure. Yeah, you can find most of it online too.
And now for something completely different.
Sure.
As I am unemployed and maybe unemployable in this uncivilized country with full employment, there are civilized countries like the Netherlands, and I am an EU citizen. So, what would be employment excuses for somebody with physics and an electrical engineering PhD? Who is trying to overcome his inertia.
So you mean to work here or to work in the Netherlands?
What is Xsens home base looking for? Who is Xsens home base looking for?
Yeah, we can put you in touch with someone that would know. I'm not really sure what. There might be like some openings on our website as well, but
I've pretty much had it with full employment.
yeah, no, there's definitely more openings in the Netherlands than there would be in LA. Thank you. Yeah, thank you. Thanks for coming.
So you're located in. Okay, but I do have your card. So I
Okay.
can follow up on that.
Yeah. Shoot me an email and I can connect you with the right people.
Thank you very much.
Thank you. Nice